Hello, let's continue our Sudoku adventure with Spill the Beans by Matt Tressel. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this green line in the grid. It's a German whisper line. What that means is that adjacent digits on the line have to have a difference of at least 3. So if this was a 2, and this was a 5, you subtract the bigger from the smaller, you get 3, and 3 is at least 3, so that's allowed. If you do a 6, 6 minus 2 is 4, that's also allowed, that is at least 3. But if I did, say, a 4, 4 minus 2 is 2, that's not at least 3, that would be disallowed. This pairing up across the line would be disallowed. All pairs need to follow that along the line. Additionally, digits may not repeat on this line, so it is a 6-cell line, so we need one of each digit on the line. And then finally, we do have these dots in the grid. These are called kropki. Digits separated by a white dot are consecutive, meaning if this was 2, this could be 1 or 3 for them to be consecutive. And digits separated by a black dot have a 1 to 2 ratio, meaning one is exactly double the other. So if this was 2, this could be 1 because 2 is double 1, or this could be 4 because 4 is double 2. Not all the dots are necessarily given. So if we had, say, 2, 4 here, there could have been a black dot. There isn't, and that's perfectly fine. We're allowed to put 2, 4 next to each other. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, we can't repeat any digits on the line. So it's going to resolve one way or another. There's only 2 ways it resolves. I already know that because a German whisper across an entire row has the same result, and if you can't repeat digits on it, it's like it's across a whole row. So what do I mean by that? Well, first we want to think about the 3 and 4 and where they go. So for example, and what's special about 3 and 4 is they only have one buddy. There's only one pairing that works. So if there was a 3 here, what is the pairing that goes with 3? Well, only 6 can go with 3. It's the only one far away enough from 3. So we'd have to put a 6 here, but we'd also have to put a 6 here. And that's not allowed. You can see actually the conflict checker is telling us that. So we have some extra like hidden region logic going on. Anyway, the conflict checker is actually telling us, hey, you can't repeat a 6 on this line. So that's not allowed. And 4 has the same issue. 4 would have to repeat the 1. So as a result, the ends are the only places we can put the 1 or the 6. Sorry, the 3 or the 4. Sorry. Because 3 or 4 isn't going to work in the middle of the line. It would have to be surrounded by the same digit. And because we can't repeat on the line, that restricts it. Now, next to the 3 and 4 are going to be the 1 and the 6. We just said 3 goes with 6, 4 goes with 1. And then that leaves just the 2 remaining digits, the 2 and 5. So this is how it's going to resolve one way or the other. When I say one way or the other, I mean either starting with 3 here or starting with 3 here. And we're going to go say 3, then 6, then 2, then 5, then 1, then 4. All right. So we have some interesting black dots, perhaps. What do we want to do here? We can think of these as pair. Well, I mean, they are pairs, right? So actually, this is an interesting pair. This 2, 5 pair here is telling us that these digits and these digits cannot be 2 or 5 because they see both the 2 and the 5 in this pairing. So if we can't put a 2 on a black dot in a 6x6, that removes 1, 2, and 2, 4, leaving just 3, 6 as an option. There's only 3 pairings: the 1, 2, the 2, 4, and the 3, 6. You can think about it as what's the lower digit, right? There's going to be like one digit is going to be lower than the other. That's hopefully obvious that they aren't the same digit, so one will be lower than the other. The lower digit gets doubled. So we can double the 1, we can double the 2, we can double the 3, but if we try to double the 4 as the lowest digit, we get an 8, and that's too big for a 6x6. So there are only 3 pairings: 1, 2, 2, 4, 3, 6. All of them involve a 2 except the 3, 6. Now that 3, 6 pair does tell us the order this goes in. So this is 4, 1, 5, 2, 6, 3. That actually resolves the 6 and 3 here. All right, this is a pair. It's going to be 2, 4. All right, this cell can't be 2 or 4, meaning this is not a 2, 4 pair. In fact, it sees a 4. So another reason it's not a 2, 4 pair. So this could be 1 with a 2 here, or we could do a 3, 6 easily. The 4 is up here. I'm just going to see if we have any interesting Sudoku to do. 6s are there. Are any of these limited? No 2 or 6. Okay, so here's a little trick for white dots. White dots always have one even and one odd on them because they're consecutive. 2 consecutive integers are always one even, one odd, because one of them will be divisible by 2 and the other one won't. We're adding 1. So we need an even digit on this white dot, and so 4 is the only option because 2 and 6 are gone. So this can't be 4. That places the 4 there. These are from 2, 3, 6. This can't be 2, and it can't be 3. Why is there a red 3? Or sorry, no, it can be 3. It can't be 6, obviously. There's a 6 in the row. Okay, so that's 3. I was very confused by that red marking because I misread it. So this can't be 6 anymore because that can't be 3. In fact, yeah, this is a 2, 6 pair. 3 ends up over here somewhere just by Sudoku. This needs to be a 1, 5 pair. This is 1, 3, 5. This is 1, 5, 6. The 6 is placed, and that's 1, 5. Over here, okay, so we can't pair the 4 with the 1, so we're going to have to pair the 4 with the 5, and then that gives the 1 there, giving us 3, 6, giving us 5, 2, 1. That's our 5. All right, up here we need 1, 2, 3. Might as well mark that. Okay, we can mark these triples, 1, 2, 5, and 3, 4, 6. That's not 3, that's not 6. Now these are consecutive, meaning this can't be 1 or 2. So it is going to be pairing with the 5. That's 4 and 5. That's 6. All right, that places the 6 here. This 1 tells us that's 2 and 1. We have the 4 and the 2. These can't be 5, that can't be 6. These can't be 1. Oops, they definitely can't be 0. What's left in this box? We have a consecutive. The 1 can't go on the consecutive because there's no 2. So that's our 1, that's 2, and that's 1. That's 3 and 2, that's 4 and 3. We get a 3 in the corner, shooting confetti, and then we get the 4 and the 5, and we're done. All right, cool. Nice puzzle, Matt. Yeah, I liked the demonstration of, a German whisper that can't repeat. A 6-long German whisper that can't repeat in a 6x6 is quite restricted. It's going to resolve, again, one way or the other. It's symmetric in that way, but... and then the interaction with this black dot was neat. The 2, 5 pair interaction with this black dot, removing 2 from here, was really neat. All right, cool. Well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.